Hi, we'd like to welcome you to another in a series of webinars designed for railroads and rail agencies. Today, we're going to focus on dynamic track charts and with our great partner, Bartlett and West. And they're going to show what they've been able to do with some of our latest technology in terms of being able to build schematics and equivalent track charts. So for us at Esri, that really is embedded in a larger framework, if you will, that we hope we're helping to define what we would hope would be the next generation of railroad information systems. As we look ahead and as we think about the amount of infrastructure spending in the current proposals, obviously we think that freight rail needs and really should play a much larger role in our nation's infrastructure and in goods movement. But to do that, I think the railroads are going to have to really invest in greater technology and in information systems and really how to use the best information systems to improve their performance and on-time deliveries. And so that really requires, in a certain sense, what we would call a comprehensive digital transformation. And ultimately, location intelligence needs to be a fundamental part of that. So before we really dive in, I want to remind everyone we are recording this presentation, and you will be able to ask questions at the end. If you type your questions into the question box, we'll allow time at the end of the webinar for your question and answers. And so with that, I'm going to go ahead, a little bit of an introduction, and then I'm going to turn it over to Tyler Remmert of Bartlett and West. But again, one of the things that I would say is that in the rail industry, there are a number of really emerging technologies and technology enablers to really help support smarter rail, artificial intelligence, machine learning, cloud technology, all of those, but really we think that there's two key components that are really critical to that sort of digital transformation in rail. And the first is really the importance of data and information. And then the second really is the power of what we call knowing where. And together, those two we define as really location intelligence. And it really is that location intelligence that we think is going to be the foundation of really being able to deliver smarter rail. And ultimately, the real goal is not just technology, but in fact, it's increased efficiencies, improved safety and security, and ultimately better customer satisfaction. And that's really the goal, I think, that everyone, and that's really the goal of why you implement these technologies. And as we said, it really sort of all begins with knowing where. The problem is that for many large rail organizations, they really haven't been able to take full advantage of all of their data and their information systems. And why is that? Well, each division has created their own track networks, their own geometries. They've attached different data to it, and they're really sort of inconsistent. And because they were really designed for different purposes, they may have been fine at one point in time, but really doesn't allow you to bring the information from across your organization together in ways that you can really optimize your performance. I think that the PTC requirements here in the US for the Class 1s really did force the greater precision in the track data, and I think that really created, in a certain sense, the infrastructure, if you will, that helps facilitate this ability really to begin to to sort of systematize and bring greater rationality to our information systems within within our railroads. And ultimately, it is that information from across your own organization that's really one of your most valuable assets. So, you know, without having that, what we call a single source of truth, what do you have? Well, as most railroads know, you have duplication. You have different groups maintaining the data across the organization, different systems, and again, it really creates that difficulty or even an inability to bring information together from across different departments that would allow you to really make better decisions. There's often a lack of standardization, and so it does make it sort of much more difficult to standardize and really to modernize processes. So we think ultimately it does begin with really having that vision that what you want to have is a single source of truth, a single geometric network that's going to allow you to sort of attach to your various business systems that would actually allow you then to share that information, and that not only would you have that core set of track geometry, but that in fact a whole host of derivative products could be generated from that same single source of truth. And that's really where we are today, that the track charts, which are really a schematic, a simplification, if you will, of those real world networks, should and can really be generated from the same single source of track geometry. And that's really what we want to highlight today. And so with that, I'd like to turn it over to Tyler Remmert of Bartlett and West, and he's going to walk you through what they have been able to achieve with Esri technology in terms of creating dynamic track charts. So Tyler, over to you.
All right, thank you so much, Terry. It's a pleasure to be here. Like Terry said, we've been focused on a kind of system of consumption for the single points of truth that you have around your rail network. The schematic is probably the best example of that. It is kind of a shorthand form, a condensed version of your geographic maps, and it's something that's very common at all the roads as a way to consume data, to share it, to work collaboratively around it. And so we've come up with this web solution that is our modern take on the track chart system. It's very configurable, so I'm going to start right out the gate by taking the constructed by band out of my track chart and replacing it with utility crossings before we get started here. And then we are going to navigate to one of my two demo subs here. So we're going to load Casey Jones sub. You can see the data start to spill in over here on the right. In our subdivision navigation pane, we've got a few other options. You could download in PDF form what you might consider a traditional track chart book based on the standard 5-mile pages that we see at most of our rail clients. You could also print this current view that we have on the screen here. I customized it, of course, by taking a band out and putting a different band in. And so if you wanted to print out this single 5-mile page in its custom format, you could do that here. We've got some kind of standard navigation for the track chart. We can move forward and backwards a 5-mile page at a time. For the purposes of the demo here, we're going to go to my favorite place on the Casey Jones sub, milepost 152, and take a look at some of the data that we are bringing in from different siloed systems into this system of consumption so that we can visualize it here in the track chart. This is our track chart is all loaded in. We've got 22 slots here in this solution of data that you could display as you choose. Probably one of the main part here, the plan view is very important. That's where the majority of the data sits. Probably a very conspicuous one is this grade profile. So this is actually generated from 3D PTC data. We've come up with some algorithms to render this in accordance with the track chart to build the traditional looking profile. It's super configurable, so you can choose the interval. Most of our clients choose not to set their old waypoints in here. You could make points along this graph and set custom intervals, but we've set just kind of a nice uniform interval across here and calculated this in real time from your already existing 3D PTC track centerline data, which is already quite an improvement over the old way of figuring grade. This way you're looking at data that's always up to date, and we've brought it in from a source that already existed, so we didn't have to reinvent the wheel, sort of like Terry talked about in the opener there. We've got some other forms of data in here, tabular data like speed limits. Some of our curve and elevation profile data also comes from a tabular source. Obviously, our utility crossings up here and the information associated with them comes from yet another place in the railroad, right, where they are charged with keeping track of that. And we've brought that into this system and displayed it in the track chart style so that you've got one more piece of data in here that you can consume. Another really awesome feature that we have in this solution is actually the real property boundaries. So the dash line here with the traditional long line double dot is the original standard for a railroad real property boundary. We've come up with an algorithm that takes those real property bounds and straightens them out and displays them relatively along the track chart here so that you get a really nice idea of your widths and the types of property that you have in here. Interestingly enough, the same algorithm that we used to straighten out the real estate was also used to render very realistic looking water features through here as you cross over rivers, streams, and such. So all data that already exists in your enterprise, and especially for things like real estate and definitely PTC, you probably already have a robust change management workflow in place. You've have a tried and true method for incorporating updates, vetting what data is good and is accepted, ready for use. And all we've done is built integrations to bring a lot of this into the schematic framework so that we can see it in a very traditional format for consumption. So there are some manual pieces to this, particularly the schematic line itself. So you can see the main line here. We've also got some side track over here, a siding that's been schematicized into a straight line. There is a little bit of manual endeavor, I guess, involved in straightening all of your geographic track out into this schematic format. Esri has some great tools for helping you get that done. In the past, if any of you have used the schematics extension, that's really the suite of tools that are used to take a geographic network and turn it into a schematicized format. Most recently, though, here at Bartlett and West, and I know also ESRI is experimenting with it, we've actually moved into trace networks and even the newer, more advanced utility networks for taking the geographic information and modeling it as a schematicized line type. So a lot of tools in there to help you do that. Some of this is automated, so the main line itself usually comes in pretty good, as well as the first set of side tracks. There's a little bit of tuning that has to be done for tracks 2 and 3, 4 out. And of course, you're always welcome to make what I call kind of cartographic adjustments to how this schematic works. On top of the schematic, you are also going to need a linear referencing system, which is something most folks that work in the PTC world are familiar with. That's a system of measures, so the mileposts or engineering stationing along this line. We do build an LRS over this so that we can display all of this data then dynamically. That's how we get the dynamic in our dynamic track chart solution. So almost any data that has a GIS location, a GPS point, or a milepost and a track segment, we can then turn into a displayed layer in this track chart solution because the main line is aware of its measure system, and we can start putting things like we've got crossings in here, we've got some stationing flags, control points, and cities all have a known milepost relative to the main line. So with the schematized main line and track and the LRS in place, you're really at a point then where you can start integrating data from PTC, from real estate, from contracting, from maintenance away, and get it displayed here dynamically and really prepared to update frequently, overnight, daily, weekly, monthly, whatever makes sense for your particular change management program or the data freshness that you have in your enterprise. All these things can kind of be churned overnight as a large integration and displayed over the top of this, which is really nice. For the LRS, I almost forgot, we've got some more great tools from ESRI. So there's out-of-the-box linear referencing tools, obviously, for managing that, but we've been experimenting with some more advanced tools like roads and highways for maintenance of the LRS going forward. It's got a lot of really awesome tools in there to help you build your linear referencing system, edit your linear referencing system, and maintain it going forward over the standard kind of out-of-the-box tools. We've also finished all of this in Arc Pro, which we're really proud of. So it's a really nice way to get your data together into a system of consumption so that everyone can check it out. But enough about the guts. Let's keep looking around at data down here. We've got some rail replacement and tie replacement information in here that came in, I'm not kidding, from an Excel spreadsheet, and we were able to put that in here with mileposts and track segments. We can visit another subdivision. So we'll move over to our Jesus Garcia sub, and we'll go visit milepost 349 here. Wait for some more data to load. All right, so same thing that we saw back on the Casey Jones sub. We've got some water features loaded in here. The real estate boundaries obviously are very prominent. We've got a PTC grade that had to reset as it hit the top bounds. So each one of these is a kind of a reset as it exceeded the page in here. All of this data, since it came from GIS, is you can interact with it the same way that you do in your GIS. So we've got the ability to select features in here. I picked my selection tool, and we can kind of just draw a box around the stuff that we have in here. And you can see the query is loading up over here. It's going to run around inside this box and find all of the features that are in here. And then we get our standard GIS interaction, right, of a pop-up window with our identify results in here. All of this stuff is exactly the same as you would see in your GIS because it's sourced from that single source of truth. We didn't, bring it in here and reconstitute it somehow other than to display it. So all of the attribution that you enjoy in your enterprise GIS, you still have access to in here. And let's see, we can go drill into something like a signal here. It's got all the standard information from PTC as well as the rest of the enterprise. We built some tools in here that we also enjoy in GIS, like the ability to highlight or flash the feature in here, or even to recenter the track chart on that feature. So again, a really powerful way to interact with data from around your enterprise in a very, very standard and well-known format. Probably one of the most amazing things, the thing everybody likes to see, is that we can still present this side by side with geographic data. So I'll take a couple of these bands out here to make some room. And we'll move the plan band up, and we will bring our map in here. Turn subdivision off, or track, so we don't get too busy. We will bring our geographic map in here. And so we can display the geographic map alongside the schematic view in here. Find milepost 350. And this is a standard GIS view with all of the stuff that we're used to seeing in here. All of the features load in with all the same amount of attribution behind them, and it gives us a really handy way, I guess, to compare the changes between schematization and the geographic network. So we've got milepost 350 up here in the top right, and we've got milepost 350 here. So for folks that want to see it in its traditional format, we've got this crossing of the creek right here displayed. Our signals that we see in the schematic view are likewise here present in the map the way that we're used to seeing them. We have some tools in here to sync the two maps. So this will, probably should have used it at the beginning, but pan the geographic map to wherever the schematic view is. And likewise, if you had moved around here in the schematic view, we've also got a way to sync the geographic map with where we are in the schematic. So, and vice versa, sync schematic to map and map to schematic. So there's been a few other solutions that were kind of rehashed versions of pipeline tools that we've seen with linked views, where as you scroll through, you know, both maps update at the same time. We chose not to implement that here in our, I guess, our user testing. We found that it sure looks neat in the demo, but it wasn't as useful in real life as we thought it would be. There's a lot of occasions where someone has the geographic map open and is looking at something and really wants to pan the schematic independently, or vice versa. They've fixed their place in the schematic and they want the freedom to move the geographic part of the map around. And so we chose to implement it that way with the independent views and then the buttons that let you sync back and forth. But a really cool way to look at the data from your enterprise in a variety of ways, both the GIS that you're used to, as well as the new kind of schematic format here that a lot of us are accustomed to. That's really everything I have to show in here, Terry. I mean, I can move a few more bands around and put things back, but that's pretty much the whole tour there. So if we've got questions or anybody wants to see anything, we'd be happy to show anything anybody'd like to hear about.
Okay, thanks, Tyler. That, and obviously, you know, really impressive work that you guys have done. I just want to sort of reiterate, obviously, with the dynamic track chart that you've generated, this could be taken, these track charts, dynamic, track charts could actually be taken into the field on an iPad. Yes, I mean that's as long as it was done respecting all safety requirements. The field crews could actually take the electronic dynamic track chart into the field with them and be able to interrogate and so forth right there in the field. Yes?
Absolutely. It was not I guess, a particular part of this scope that we develop it for mobile when we came up with this solution for our couple of clients, but we have found that, yes, it operates just fine in I believe it's Safari browser there on an iPad, but operates just fine in Safari browser, and you nailed it. As long as you are respecting all of the relevant safety restrictions for your focus while you're on rail property and the use of digital devices, the solution does work just like this in a web browser. We've toyed with the idea, obviously, that if we wanted this to be a little more touch friendly, that we might revisit some of the spacing of the tools over here and the buttons up here along the top. This one was particularly designed for mousing about, but in a touch environment that we might revisit the size of some of these buttons and things. But it does indeed work just fine on an iPad, or it will actually load on a mobile phone, but there's a lot of data in there for that screen that size. But yes, yep, absolutely. But it does work just fine.
Yeah, okay, great. And, obviously some of the aesthetics are configurable to, every rail organization is going to have their own little tweaks and so forth. But I think that, certainly what we see is that this really provides an alternative to the really sort of the PDF or the paper version, although there was a question that can you actually print these as PDFs?
Yeah, absolutely. So I can print this customized view here with the print current page button. Otherwise, this download track chart book is actually each night when the integration runs, we republish this dynamic track chart with whatever changed in the field yesterday, or in the office through GIS change management processes. A new track chart gets published. The enterprise is sort of set on a standardized track chart, kind of something you were after there, Terry, that we really need to set a standard. And so the enterprise is set kind of a standard for what all bands should be in here, and that it's on a 5-mile page. That is configurable. So if, for instance, the folks in Signal had need to publish a very specific, very customized version of the track chart for their needs, maybe they don't need the joint replacements or the speed limits in there. The integrations that we've built could be reconfigured or extended to allow them to publish a very customized 5-mile page track chart book that has the entirety of the sub in there.
Okay, so there is a question, I guess, sort of getting at, do you have a little more complex, could you show an area that has 3 or 4 tracks? Do you have an area within the subdivision that?
That's a great question. I don't have one off the top of my head. We could browse through here and see what we run into, but we did have to develop some multi-track areas in this process, and they can get a little bit busy, but let's try the very end of this sub. See if we find one. Well, I'll keep browsing through here, but yes, we did have to deal with multi-track yards, joint use facilities where maybe you've got intermodal or you've got more than one rail together in a very dense urban area like Chicago. And absolutely, there are provisions for multi-main, so main 1, 2, and 3, and then even multi-track yards out to, let's see, the width of this, we could probably get about 15 tracks in here for a multi-track yard, but yes, handles it just fine.
Okay, and the follow-on question, are you able to move the order of they call them the swim lanes? I assume if you want to just show how you can rearrange the bands.
Yeah, absolutely. Yeah, we can reorder them. So here I'll take our gross tonnage and I'll put it on top of our speed. Yeah, absolutely. The ordering can definitely be changed, and if you try to fit one in here that doesn't fit, you get a little warning that says your band is occupied, and it's not gonna fit in here if you pick a big one. So.
All right. Another question, is the grade able to have vertical curves?
Oh, excellent question. I suppose that it's possible. No one's ever asked me to make one, but um, yeah, all the data that you need is there. We'd need to work up a math formula for it, but
And another question, whether the plan section, did that originally come from a CAD file, or how was the plan section generated?
the plan section. So this particular plan section mimics a track chart that already existed from one of our clients, and it was produced in CAD MicroStation. We could make it look like anything, I suppose, but no, this was fully made in Arc Pro and trace network to schematicize the main line and any of the siding and turnout tracks. And then all the rest of this data is sourced directly from a production GIS environment. So the real property bounds came from a real estate SDE. Rivers and waterways came straight from the waterways features on AGOL Living Atlas, right? Same thing, signals from the signal group, road crossing from the road crossing management system, all brought here and just displayed over the top. But it was purposely made to look very CAD-like. That's how the original track charts at this particular client looked, and we mimicked that symbology just because that's what everybody's used to.
Yeah. Okay. So another question: how is the infrastructure data being loaded into the track chart system? And it goes on to say, is there a way for integration between Esri products and databases such as a SQL database or others? And maybe you again kind of want to iterate the multiple sources of data that's really being brought into the track chart here.
Absolutely, absolutely. So yes, this data all came from very disparate systems. So the majority of this particular data came from Microsoft SQL databases, and most of them running an ESRI SDE. It's not a problem to bring in data from some other partners and environments, like SAP HANA is pretty popular. Oracle Spatial is another place that we run into a lot of rail data. Like I said, the tie and rail replacement data down here, I'm not kidding, literally came from Microsoft Excel spreadsheet. How is it loaded? For things like the Excel spreadsheet, obviously we have an integration that stages it in a SQL table, and then we make sure that everything is assigned some kind of milepost or a relative placement along the mainline LRS, and then we display as event, I guess, is the tool in ESRI's toolbox there that drapes all these features over the LRS. The integrations themselves are probably just as varied as the environments from which the data comes. We've got some Python work in here. We've got some arcade labeling. We've got integration solutions from enterprise buses and programming APIs. We've got information that is transformed from our partners at SAFE with feature manipulation engine, FME. We have a pretty big variety, and it really depends on where we're trying to pull the data from and what already exists. We don't want to change the way that real estate does business. We just want to take that data and get it into the track chart, right? So that means we also have to be very flexible with our integrations.
And that is, of course, the beauty of GIS, is that it allows you to bring together all that information, as long as you have those common reference points, the LRS and location data. Another question, is all of this housed on site, or do you host it for your clients? How's that, or can that be done in both ways?
That can be done both ways, and actually a third in the cloud, I guess, if you prefer. I forgot the list already, but for the majority of the clients that are using some flavor of this solution, they are hosting it on their site for them and their infrastructure. It's not a problem for Bartlett and West or other vendor partners to host it and serve it out to the client. And then also there's one that we haven't built too much of, but it is within the realm of possibility that this could all be housed in a cloud infrastructure, whether that's something like AGOL or just like a fully custom code and maybe like an Azure platform or something like that, Amazon Web Services, where this could be housed in the cloud and we could work that out. So it's just GIS data, and Esri has a great number of flexible ways to host GIS data, and you get the same options here with this solution.
Okay, and another question, do you have any examples with multiple mainline track?
Multiple main, yep, I was supposed to be searching for a multiple mainline. I'm sorry, I don't have one written down. I know it's very,
all right,
very popular.
Yeah, you do know, I mean, in essence, it can be done, and you have done it. It's just finding a location that
Yes, absolutely. I'm gonna write one down so that the next time I give this, I can zoom right to it and say, yes, look, here's multi-track right here. So it doesn't look like I have any on this sub, but I mean, this is probably too deep. Track here is as good as we get, but double main is absolutely possible. So you end up with the same thing, right? You have to schematicize that track and have an LRS for it. And if you've got signals that are tied to main 2 at milepost 100, they display just the same as signals on main 1 at milepost 250. You could even have different LRSs. Occasionally, some folks have a numbering system that's one direction on main 1 and another direction on main 2. They're managed as 2 separate networks, kind of like you were talking about having more than one network, right? Same idea there. The data, whichever LRS it's closest to, we would assign it to and use that as our display.
Right. So I guess there's another question relating to, I guess, the metadata. The question is, can you easily check the source and the date of the data on the track chart? And I guess that's really getting at, kind of validating the currency and, when was it last updated? And
Sure. So almost all of this data has the standard, what we call housekeeping fields, right? So last updated, date created, and all that kind of stuff. And so that is available in here in the features when you do an identify, the same way you would enjoy that same feature in your GIS.
And so ostensibly, these dynamic track charts could actually then be integrated with, for example, a inspection or maintenance management, whether it's SAP, whether it's Maximo, etc. And so updates could come from the field, and that would could you maybe talk about how you or how an agency would continuously update the information?
Sure. So the data that feeds this uses just your standard change management practice. So if you've got folks in the field that cut in a switch, they would follow your standard procedure for making a change in GIS. They would record the location of the switch, the information about the switch, and all that kind of stuff. And then they would post that change or that information from the field. There it moves from field to office. And then in the office, you've got your kind of change management process there where maybe we check the information that's submitted. We make sure that that the edits make sense or what have you, and we post that as authoritative, at which point that data then is live in production. And each night then the integration would pick up that new switch, and it would be available here in the track chart. So we're really not trying to make any, there aren't any special provisions for the person in the field that's recording or changing or deleting a new GIS feature specific to facilitate track charts. Really, we tried to have this be a system of display that takes what's already there in your authoritative systems and just displays it in this familiar format. We didn't want the person in the field to have to fill out an extra form to facilitate the schematic, right? They just want to do their regular job out there and not have that change.
Right. Okay, another question, can operational data be interpolated?
Can operational data be interpolated? So I will, I guess, expect that to mean something like, can we've got some feature that came in by GPS, right? And it's here on the map. It doesn't inherently have a milepost. Yes, we would take features like that exist in the GIS without a milepost attribute, and we would temporarily assign a milepost value to them so that we could display the event here in the schematic. Same with any kind of, it would be the same thing for like live data. So if you've got motive power out there with telemetry, a GPS ping that shows where the locomotive is right now, it would be the same thing. We would just need to move into maybe some big data ideas, something like Esri's velocity, where we're taking near real-time pings from telemetry and very quickly assigning them a milepost and refreshing the layer here in the schematic.
Right, and you'd probably have a different, more simplified schematic if you were really going to use it for operational purposes. But in fact, you could integrate that real-time telemetry data. So there is a question about being able to see what one of the published track charts looks like. Are you able to do that on it? Or
let's see. No, I'm sorry. I don't have one that's anonymized. My client was very kind to let me use this data, but I don't have what we call the paper track chart. I don't have one that's anonymized and ready to look at. I can just say it looks a lot like this. It's a very standard track chart, right? The algorithm that publishes the track chart book does put a title page on it, an overview map of the entire sub, as well as an addendum of business track locations and their lengths. But that's all GIS computation, really. It's not specific to schematics, and kind of assembles that all into one PDF.
Okay, so there is a question, and I'm going to help sort of answer. It says, can data, for example, new crossings or turnouts, be updated by field personnel? They're saying probably for non-PTC railroads. I guess going back to your comment, this is really a consumption application. That is, it's designed really to primarily just display. It's really not in this format designed to be that data collection, although presumably one could sort of take elements of this and really put it into, let's say, a survey 123 field inspection application or field data collection application, and track charts could be incorporated with field data collection activities. Yes, would that be?
Absolutely. So that's a great question. This was not envisioned as an editing environment on its own. And so for some things like road crossings is an example, that is a PTC required feature, and there are very particular requirements for capturing the edge of pavement and edge of pavement on those. If you were just kind of manually doing that with your finger here on the track chart page, I don't know that you could manually input information like that. For something like a culvert, maybe you could place that here in the schematic view, and we could, reconstitute that as a geographic feature, and that might be appropriate because they don't impact PTC. Obviously, some of the attribute information about a road crossing, we could turn the schematic solution into an editing environment, or like you said, maybe we jump off into something like field maps or survey 123, where you could answer some questions about that road crossing, like when was the last time it was inspected, what's the state of the protective equipment there, the signals flashers, cross bucks, the gates. There's edits like that that you could make safely and reasonably here in the schematic environment, but this particular solution wasn't meant to be an editing environment. It was meant only for consumption.
Okay, let's see. And another question, can you make inset pages with a different layout than the rest of the track chart?
Oh, that's great. Not here in this one, but definitely the technology is there. So we would have basically a frame inside of a frame, right, where we would do a smaller one. A lot of the 5 mile pages here are built on data-driven pages. I'm sorry, that's the old name for it, Terry. I can't think of what it's called in ArcPro right off the top of my head, but using data-driven pages, it is possible that you could configure page polygons or boundary grid that was meant to display an inset, and that you could get the insets put in here. Yeah.
Okay, and let's see, another question, and I guess this is going back to the operational. Can operational data be interpolated in real time to make decisions related to rail replacement?
Wow, that's a humdinger of a question, Terry. My answer would be yes. I don't have one here in this particular solution, but could we take a stream of real-time or near real-time data, display it in a schematic format in real-time or near real-time, and could we then use geospatial or spatiotemporal analytics to make some decisions about the future, such as, has this been maintained? Should it be maintained? Should I make some correction in the future? We could absolutely put all of that in here, up to and including machine learning, to help you make the decisions about future maintenance, right? Predictive maintenance of equipment. Absolutely. And since it all has location as a common denominator, there's no reason why that could not all be displayed here in the schematic view.
And actually, I mean, if you think about that, I do think that's a great question, in that, increasingly, locomotives have a range of sensors, and some of those sensors can detect certain some vibration, etc. And that can be sent back in real time. That can be identified on the track chart, and really can be an integral part, really, of a sort of a predictive maintenance set of activities ultimately. And I think that's really where many railroads really want to head. So no, great question. So there's a question, and I guess getting back to your word, schematicize. Can you maybe just briefly speak to the level of effort to really required to quote schematicize, and maybe you could sort of speak to kind of your experience with trace network, and kind of how easy or the maybe the steps in creating the schematic.
Sure. So there's a little bit of upfront work in configuring a trace network if you're going to bring your geographic data that's part of a geometric network into the world of trace network and turn it into a schematic or straight line diagram. How much is the effort? Really depends on some of these simpler places here where we have a single main. It's really not that bad. In fact, if you've got just a single main and it's straight for all 100 miles of your sub, when you bring that into trace network, the schematization tools, I'm not sure any of that's really a word, but we're going to use it. The schematization tools in there can straighten that thing out, and it's really not a problem. It takes very little work. Most of the places where you are going to have some manual effort is multi-main areas, places that have a high number of turnouts, simple single turnouts and simple single side tracks. Most of them require very little manual effort. They just kind of come in, and the algorithms that are part of Trace Network facilitate that. There's not a lot to mess with. Kind of like any kind of GIS, really the big beast is yards, right? If you've got a huge multi-track yard in there with a bunch of leads in and out and all that kind of stuff, you need to spend a little bit of time in there making sure that the algorithms offset everything correctly. Another place might be some other more complex geometries like a loop track or a Y track, where you might need to go in and manually adjust the way that looks in the straight line diagram, just so that it's I guess logically sane as well as cartographically pleasing. It's worth it. And then once you have to maintain it, maintaining it is pretty easy, actually. If you're going to relegate your schematic to a 5-mile view, it takes quite a bit of change in that track to necessitate a change in the schematic. So you need to extend a siding that dead ends or a storage track or something more than 1,000 feet before you would need to consider how that might be a change in its view in the schematic, because you're looking at a 5-mile scale. So definitely worth the upfront work to get your track into the trace network in the schematic format. I mean, the rest of that LRS, that effort for maintaining the LRS over the schematic track really isn't that different than any of the other LRSs you might maintain at the railroad.
Okay, and again, there's a question relating to, can this be, I guess if you could go back to showing the map on the sort of the plan at the top and the map at the bottom, if you could show that, and it has to do with really being able to link to a geospatial database, which I think is actually what you had. So in other words, you have a real world network taken from the GIS. In that particular case, you were really just showing it on top of a digital ortho, but that could really be any type of map at the bottom. Yes, I mean, that could just be a 2D.
Absolutely, yeah. Yep. We could even do probably a 3D scene from a solution like ArcGlobe or something like that. Right. Live tech demo, it looks like my plan view has had enough today.
I see. Well, okay.
But anyway, we can get the map back in here also and click on some of the stuff in there. Yep, and this is just this is standard GIS. This isn't actually like from a separate database that's here's all the schematic stuff. This is straight from the production GIS environment, and um, we could run our
It's
same feature selectors on it and everything. It's live from production SDE.
right. And so in essence, it's the same. And again, going back to that point, it's the same source for the information, both for the GIS view in the bottom to the GIS view on the schematic on the top. It's really being generated from the same source of that single source of truth that we use.
It is the schematic view up here is really just a re-symbolization of the stuff in the geographic view down here.
Yep. Yeah. So okay. And then another question really relating, and I guess every railroad kind of wants to have this look a sort of a slightly different way. They have their own customized. Is that, I guess there was a question related to, is this a standard, or has this been configured for the particular railroad? And
Each of the deployments of our solution is bespoke. It is custom for the railroad. I keep trying to convince people to make one that looks like Tony Stark in the Avengers. I don't own that trademark, so no copyright infringement, but blue hologram on black, right? No one's taking me up on it. Everyone wants it to look like CAD, but yeah, it's absolutely customizable. The labels, it's every kind of flexibility that you enjoy in GIS. It's the same thing here. It's just in a straight line diagram. So custom labels, custom symbology, custom data bands, custom slots, custom interface, custom logos, anything you want. So it's all just code. It's configurable. All of it's configurable.
Yeah. So, with that, I think we've reached the end, and Tyler, I want to thank you. This has really been tremendous. Again, I want to reemphasize that point. It's the same central source of data that's actually generating both of those views that you saw, and we see that this is a central or an integral part of really having that more coherent, more rationalized set of information systems that really support across the rail organization. So Tyler and Bartlett and West, thanks so much for presenting today, and we want to thank all of you for attending, and we hope to see you at the next rail webinar. So with that, we'll go ahead and sign off, and thanks everyone. Right. Bye-bye.